Hi all, welcome to the next episode of question paper based discussion session. Today we will be discussing question number 35 and 36. These two questions usually come from the applications of light chapter and electricity chapter. Those who haven't watched the previous videos, kindly go back and watch it. Let's begin. Let's see the first question. A person needs a lens of power 4.5 diopter. The power of the lens is given. What kind of defect in vision is the person suffering from? Show it diagrammatically. What is the nature of the corrective lens? What is the focal length of the corrective lens? These are the questions. Let's see the first one. A person needs a lens of power 4.5 diopter. So person needs a lens of power 4.5 diopter. So this is plus 4.5. Since this is a positive value, its focal length is also a positive value. When the power of lens or the focal length of the lens is a positive value, it's always convex lens. We know that one. So if the person is using convex lens, then the person is suffering from hypermetropia. Hypermetropia. Suppose if it was concave lens, then it is myopia. So first question was, what kind of defect in vision is he suffering from? So the person is suffering from hypermetropia. Then show it diagrammatically. If it is hypermetropia, the person will be able to see the faraway things clearly, but he won't be able to see the nearby things. So if this is the eye of the person, then if this is the near point, then when the light ray is coming from the near point, already one convex lens is there inside. So when the light ray comes from the near point, it will go and fall behind the lens, behind the retina of the eye. So it will cross the retina and go outside. So the person will not be able to see. So this is the defect of the person. Now suppose if they're asking us to correct it, then we'll have to keep a convex lens in between, in front of the eye, so that the ray will converge and it will fall exactly on the retina. This is how we correct it. So now they haven't asked us to correct it. They just asked what is the defect, show the defect. So defect is hypermetropia and the lens used is convex lens. So the nature of lens is convex and this is the defect. Now what is the focal length of the corrective lens? We know the relation between the focal length and the power. Power is equal to 1 by focal length. So here power is 4.5, that is equal to 1 by focal length. If you just interchange, F is equal to 1 by 4.5. I'll just rewrite once again. F is equal to 1 by 4.5 into 10 into 10. So F becomes 10 by 45. So when we divide 10 divided by 45, it won't go in this 0, then 100.2, we'll get 90, then again remaining 10, it will keep on going. We'll get F is equal to 0.222. It is focal length and we got it from the power. Power is shown in diopter, which is the SI unit. So same way, when we get the focal length, here also it will be in the SI unit, that is meter. Usually when we write the focal length, we'll be expressing everything in centimeter. So there will be a tendency for us to write it in centimeter. But please see that here the power is given in diopter. The power is in diopter. Since the power is in diopter, here our focal length also will be in the SI unit, that is meter. So write it in meter. If needed, we can just convert it to centimeter. F is equal to meter to centimeter. We'll just multiply with 1 meter is 100 centimeter. So multiply with 100. So it is 22.2 centimeter. Not compulsory. This is enough. So the focal length is 0.222 meter. So they told us that the person is using a lens of power 4.5 diopter. So from that we understood that the person is suffering from hypermetropia and the lens used is convex lens and the power of lens is 1 by F So F is equal to 1 by 4.5. We got 22.2 centimeter or 0.22 meter. Here, this is how the defect is. Any one of the defects of vision will be surely asked for the exam. So kindly study the defect of vision, its cause, and how to correct it with the ray diagram. We'll go to the next question. Next question is, what is a solenoid? Draw the pattern of magnetic field lines around a current carrying solenoid. Mark on the pattern the region where the magnetic field is uniform. So this is the question. So first of all, what is a solenoid? We know a solenoid is a coil of insulated copper wire wound in the form of a cylinder that acts as a magnet when electric current passes through it. So our solenoid is something like this. It is connected to a cell. This is the solenoid. This is made of insulated copper wire and it is wound in the form of a cylinder. When the current passes through it, it behaves like a magnet. Now we have to mark the magnetic field lines coming out from it. So we know solenoid is similar to a bar magnet. So the magnetic field lines will be similar to that of the bar magnet. It will not touch each other. Here also we have the field lines like this. Now one more thing is, here the current is flowing in this direction. The current is flowing like this. It's coming in like this. Then again here it's coming out like this. It's reaching back to the cell. So now, since the current is flowing like this, from this side, when we look, it's flowing in a clockwise direction. So when the current is flowing in a clockwise direction, we have already studied that the south pole will come here. When we see this, here you see it's in clockwise direction, here also in clockwise direction. So here it will be south pole. When we come here, when we look from here, here it is coming out. So when we look from this direction, the direction of current is an anti-clockwise direction. So it is north pole. So when it is north pole, you can see here it is anti-clockwise direction. So this direction will be north pole and this direction will be south pole. Again, field lines are going out from here, north to south. So here also it's coming like this. So we'll mark the direction also. Direction is from north to south. So this will be the direction, north to south. North to south. It's coming to south, it's going out of north. So north to south. Okay. So this is how it is. Next question was, where will be the magnetic field uniform? We have to show that one. We know in a solenoid, at the center of the solenoid, magnetic field line is uniform. So we have to draw straight lines here inside the solenoid. We know outside the direction of magnetic field is from north to south, but inside it is from south to north. Maybe that's the reason why they have asked it. We'll be mostly confused. So it is from south to north inside the solenoid. So that we'll get a closed path. Okay. So these are the answers. So this is how to draw the solenoid. So again they can ask questions, similar questions. If you increase the current, what will happen to the magnetic field? It will also increase. Then if you increase the turns of the solenoid, what will happen? Again the current will increase. They are all directly proportional. If you increase the current twice, the magnetic field will also increase twice. If you increase the circles or the turns twice, again the magnetic field will increase twice. We can expect questions like that. Now we'll go to the next question. Next question is, what is Joule's heating effect? What is that effect? List the applications of Joule's heating effect in our daily life. So what is Joule's heating effect? When electric current passes through a current carrying material, it will produce heat. That is heating effect, Joule's heating effect. The mathematical statement is H is equal to I square RT. So when current increases, the heat increases. When resistance increases, again heat increases. Then when the time increases, again heat increases. So this is the mathematical statement of Joule's heating effect. The main point is whenever current passes through a current carrying conductor, there the heat also increases. When current is passing through something, the heat increases. So where do we use it? What are the applications of it? The applications are electric bulb, usually in filament bulb and all, the tungsten. It will get heated and it will give the glow, the current, the light will come off. Then electric heaters. In heaters also, when the current passes, the heat will increase. Then electric fuses. The fuse also works based on this principle. We have seen this two times in our textbook. So when current passes through the fuse, there is a particular limit for the current which can pass through a fuse. Then when the current crosses that limit and excess current passes through it, the heat also increases and the fuse will not be able to withstand that much heat and the fuse will start melting. So that excess current will not reach our house and our house and the equipments will be saved. The next is electric toasters. Again, our iron box. Iron box also works based on this principle. We already know when the current passes, the iron box get heated. That's it. So we'll go to the next question. A student sitting at the back of the classroom, cannot read clearly the letters written on the blackboard. What advice will a doctor give to her? So first of all, the child is not able to read anything clearly. So the doctor will obviously ask the child to use a spectacle of appropriate power. So let's see what's the issue of the child. The child is sitting at the back of the classroom and can't see the blackboard. So the child cannot see far away things clearly. So the issue for the child is myopia. Myopia is the issue. So the doctor might ask the child to wear a concave lens of appropriate focal length or appropriate power. Okay, so this will be the advice given by the doctor. Since the child cannot see far away things, it's myopia, and the lens used is concave lens of appropriate focal length. We'll go to the next one. Here, a narrow beam PQ, we can see PQ here, a narrow beam PQ is coming here, is passing through a glass prism ABC as shown in the diagram. Trace it on your answer sheet and show the path of the emergent beam as observed on screen DE. Here a screen DE is kept, so the light will come through the prism, it will come out like this and will fall on the screen. So we have to draw which color will be coming out, how will it be. So first of all, let's trace it. So here, after coming out, it will disperse into all the 7 colors and it will fall on the screen. The order matters. So here we know at the bottom we have violet, then indigo, blue, green, yellow, orange and red. Okay. So questions based on prism, they'll be usually asking. In the previous questions also we have seen similar questions. So this portion is very, very important. First question is, write the name and cause of the phenomenon observed. So what is the name of the phenomenon? The name is dispersion. Dispersion of light. That's how it is splitting into 7 different colors. The cause is, it's because of the difference in the wavelength of the light, due to which the speed of each color will be different. The wavelength is different. Difference in wavelength of each color, due to which the speed of each color will be different. That's why different colors bending in different way, getting dispersed in different way. Next one is, where else in nature is this phenomenon observed? Where do we see these 7 colors? In rainbow. We see this inside in the rainbow. So in rainbow, here we have this glass prism, but in rainbow, instead of glass prism, we have the water droplet. So there, the water droplet act as a prism. So where else in nature is this phenomenon observed? It's observed in rainbow, where the water droplets behave like a prism. Next one, based on this observation, state the conclusion which can be drawn about the constituents of white light. White light consists of 7 colors. We'll come to the conclusion that white light consists of 7 colors. It's called the spectrum. Spectrum of white light. Spectrum. That's it. Let's see the questions given in the CBSE model paper as well. Let's go there and see. This is question number 35 given in CBSE model paper. Here, this question is also related to the defects of vision. The question is, the above image shows a corrective measure for a particular defect of vision. So here the correction is shown. Identify the defect. First of all, identify the defect of vision and state what kind of lens is used to correct this deficiency. It's already given that it's very simple. So the lens used here is convex lens. As we can see, it's convex lens. Just now we have discussed a similar question. So if it is convex lens, the defect is hypermetropia. So the defect is hypermetropia. The person will not be able to read the nearby things properly. Now draw and label a ray diagram that shows the defect of vision in the above case before correction. Here they have given the correction. So before correction, how will it be? We have to draw that one. So before correction, this lens will not be there. The ray of light will go like this. It will reach the convex lens inside the eye, and from there it will converge. But the convergence will happen outside the retina. This will be how it is. Then later, if we use a convex lens in front of the eye, then it will be corrected and will fall exactly on the retina. Okay. We'll go to the question number 36 in this question paper. In question number 36, a student needs to make a 0.12 ohm resistor. She has some copper wire of 0.80 millimeter in diameter, and the resistivity is also given. We have to determine the cross-sectional area. The cross-sectional area of the wire should be determined, and we have to calculate the length of the wire required for 0.12 ohm resistor, which is given in the question. So we have to find out the cross-sectional area and the length of the wire. We'll take it to the slide. We'll do it there. Let's write the given values first. 0.12 ohm resistor. So resistance is given as 0.12 ohm. She has a copper wire of 0.80 millimeter diameter. So diameter is given, that is 0.8 millimeter. We should write everything in SI unit. So millimeter, when we convert to meter, it should be divided with 1000. So 0.8 divided by 1000, which is same as into 10 raised to minus 3. That is 0.8 into 10 raised to minus 3 meter will be the diameter. Now the resistivity is also given, that is 1.8 into 10 raised to minus 8 ohm meter. So resistivity is equal to 1.8 into 10 raised to minus 8 ohm meter. First question is determine the cross-sectional area of the wire. If we consider a wire, the wire is similar to a cylinder. So they are asking us to find out the cross-sectional area of the wire, which means that this area, that area is similar to the area of a circle, that is pi r square. We have to find out pi r square. For that, we have to find out the radius. Already diameter is given here. We know the radius is half of diameter. So r is equal to d by 2. That is equal to 0.8 into 10 raised to minus 3 divided by 2. So 0.8 divided by 2 will get 0.4 into 10 raised to minus 3 meter. Now we'll go to the first question. Determine the cross-sectional area of the wire. So cross-sectional area. Area is equal to pi r square. That is equal to 3.14 into r. R is 0.4 into 10 raised to minus 3 whole square. Now that is equal to 3.14 into 0.4 whole square. 4 4s are 16. So it is 0.16 into 10 raised to minus 3 whole raised to 2. So we have to multiply 3 and 2. We'll get 10 raised to minus 6. Now multiplying 3.14 into 0.16. Now we will get 0.502 into 10 raised to minus 6. This is not the standard way of writing. We have to take this decimal towards the right side. For that, we should multiply here with 10. When we multiply here, we should divide with 10 also. That division will be done here. So 10 raised to minus 6 becomes minus 7. So our final answer will be 5.02 into 10 raised to minus 7. Its area, so it is meter square. This is our final answer. Now we'll go to the second part of the question where we have to calculate the length of the wire. We know the equation connecting all these, that is rho is equal to RA by L. Now rho, resistivity, that value is given here, that is 1.8 into 10 raised to minus 8, that is equal to resistance R is equal to 0.12 into area of cross section is given here, that is 5.02 into 10 raised to minus 7 divided by L. Length is not given, we have to find out that. Now I'll take L here, so L is equal to 0.12 into 5.02 into 10 raised to minus 7 all divided by 1.8 into 10 raised to minus 8. Here we have a 10 raised to minus 7 and 10 raised to minus 8. Both will get cancelled and 10 raised to minus 1 will remain here. So now it will be L is equal to 0.12 into 5.02 divided by 1.8 into 10 raised to minus 7. Now we'll multiply these two. When we multiply these two, we will get L is equal to 0.6024 divided by 1.8 into 10 raised to minus 7. As we know, it is 0.18. When we divide both, we'll get the answer that is equal to 3.34 meter. So we got both the answers. First one was to find out the area of cross section, that we used pi r square and we got this answer. And now the resistivity, rho is equal to Ra by L or R is equal to rho L by A. Using that one, we got length is 3.34 meter.